So the topic given to me is enabling technologies for solar system explorations. So here actually we see the titles. We should understand what do you mean by enabling technologies. So what do you mean by solar systems? So and what actually the explorations. So there are three contents are there. So I will just start these contents one by one. So what do you mean by enabling technologies? You might have heard about many technologies, but what do you mean by enabling technologies? And innovations, then actually you may be knowing about inventions. So those differences, apart from that, enabling technologies, if you see, go by definitions, these are, it can be technical concepts, it can be materials, it can be devices, it can be processes, which are developed in one technology and used in another technology to enable advances, new understanding, software and applications. Suppose, let us say like, suppose mobile phone. If you say the mobile phone, the smartphone, enabling technologies could be your Android the software, because Android software is actually different platform. But smartphone is hardware. So software is actually the development in the technology in the software is enabled to develop the hardware. Okay. So, but these technologies are not end products themselves. So they serve as a foundations tool that enables other technologies to function more efficiently. So the figure one here, if you see here, just 1 minute, I'll just, yeah. So if you see here, this is called the famous S curve. So when you see, because as a student, you may be actually undertaking different technologies, but how do you monitor the progress of the technology? So that actually is given by called S curve. So here the shape performance versus effort, if you see the R&D effort, so you can see the shape is like a S curve. So it has different slopes. So initially when you're, because in the beginning when the effort is zero, the performance is also zero. When you start putting effort, the performance also increasing, keeps on increasing. But you cannot actually further increase the performance even though you increase the effort. So there is a limit, fundamental limit of the particular technology. So before reaching the limit, you have to start a new technology. So there is actually what happens is technology gap or discontinuity. This is how the technologies progress. If you see here, you can see the below. So like suppose the incubations, then the progress, tech off, maturity and discontinuity like that, because some technologies cannot be because perpetually available, so they become absolute. Another class of technology is called the disruptive technologies. So these differences you try to understand, because this is very important. So when we talk about what do you mean by enabling and what do you mean by disruptive? Disruptive technologies are a class of technologies that can disrupt the market. Okay, they can introduce a totally new approaches, new solutions to the market, and whatever they are available in the market will be totally disturbed and make the available, the earlier versions will be obsolete. Okay, so the, let us say the familiar example of disruptive technology is the wheel. The invention of wheels actually makes the our transportation systems very revolutionary. Till now, there is no any other wheel shape other than this round shape, because you just try to think anything, any wheel shape other than this one. You see, this was actually in the prehistory time the wheel was actually invented. Okay. Then another is the smartphone. We are using earlier actually the keypad versions. Then after that the smartphone has come. Smartphone has many features which can do, even actually we can do everything, all the functions, all other gadgets we can. We have a facility in the smartphone. Then another facility in the digital photography. You can see earlier we have this film photography, and eventually the digital photography came, and now we cannot no longer see this kind of film photography. Then like invention of computer, typewriter is not there. So these are the actual examples of disruptive technology. Now I think you might have understand what is the difference between enabling technology and disruptive technology. So now the solar systems. So when we say the enabling technologies for solar system explorations, so what is the size of the solar systems? Okay, so if you see, this is the actually. So you see that the distance between sun and earth is called one astronomical unit, 150 million kilometers. So the solar systems, the influence, okay. So what happens is the heliopause means the influence of the sun is still there up to this, and after that subsequently is also there, but what happens is little relatively weaker. So the 1.5 light years is the radius of the solar system, or otherwise 1 lakh astronomical unit. That means the end of the Oort cloud. So the starting from the sun, at the end of the Oort cloud is actually the size of the solar systems. So beyond that, our nearest star will be Alpha Centauri, which is approximately 4.3. You can see here So different radius are there, 2 light year radius, 1.5, then 4 light year radius. So nearest star Alpha Centauri will be in the 4 light year radius. So it's not possible to travel. Then why explorations? Because why you want to explore the solar, solar system? Because the explorations will help to understand the formation of this one, because we don't know how the solar system was formed, how the universe was formed. Because of exploration, our curiosity only makes us to understand. And not only that, the second questions we keep on asking is, are we alone in the universe? Okay, really, because really we are only alone in the universe, because we have been sending less kind of our hello message to find out any response has come from the space, but still now nobody actually has responded to us. And also we want to expand the horizon of our technology and innovations by doing explorations, and we also inspire our curiosity and imaginations. And ultimately we want to, because out of human curiosity we want to explore the more and more. Okay, so there are different types of explorations. One is called the flyby. Flyby means near the planet, because this orbit, what happens is you will just go and pass by near to that, and during that pass by period closer to the planet, you can do some experiments, and after that you will be like going just like comet. Okay, so then another is orbiter. Like suppose you may be knowing that because these are called, like suppose these are orbits, you know. And here you must know that what is the difference between spacecraft and a satellite. Because when you say the satellite, because the spacecraft could be anywhere. When we say the satellite, it should have a different, like suppose within this influence of the, let us say, the planet, or otherwise the celestial body. But when you say the spacecraft, it can be actually go to interstellar medium and go to another planet, and it's called a spacecraft. The lander means this is a class of this one. We should land on the surface of the planet or celestial body and do the experiments for explorations. Another class is a mobile rover kind of things. They will roam on the surface, then after that do various measurements. Another class is copter. You may be knowing, heard about this Ingenuity copter, which actually nobody could imagine that the helicopter can be flown in the atmosphere of the Mars. But actually our humans, scientists, team of scientists and technologists, they have demonstrated flying helicopter Ingenuity on the surface of the Mars and trying to explore such kind of helicopters more in other planets. So when you talk about elements of explorations, okay, so to explore that, what I have to do, I should first reach there, because without reaching there, I cannot do any explorations. So for that, what I should do, I should have a propulsion system first to reach the place where I want to explore. Second, then after reaching there, what I have to do, because the things, see what happen is these robotics elements is required, because I cannot go in the first go, because as Dr. Ganesh also mentioned that the thing is these environments, the planetary environments are very harsh. It's not like habitable for us. So we have to actually send robots first to see, to explore the condition first. Then everything I cannot carry from Earth, because it will be very heavy. I have to go there, reach there, come back, and everything will be very actually the heavy voluminous kind of things. So this is what Dr. Ganesh has given a talk, because in situ resource utilizations. So whatever available resources, I should make use of explorations and returns and coming. Then how to explore it? Different kinds of payloads. Yes, I have mentioned that rovers, copters, payloads, different kinds of payloads. I understand that there was a separate talks, and Dr. Das also has given in the first day inaugurations different types of payloads and how to explore this. And later on, since the surface is not habitable or environment is not habitable, I should be safe and sustained there. So I need a protection, life support systems, and the system should be actually less in human intervention, because it should be self-sustained and it should be intelligent systems. We need AI technology navigation systems. And after reaching there, I should communicate to the Mother Earth that where I am and what I am doing there, whether I am alive, and all these things, communication technology is required. And for doing all these things, we need power. So we need the power sources. Okay. So when we say the enabling technologies, all technologies in these domains are required. Okay. So I'll be just touching a little bit of this. It's not possible to touch upon all in this session. So when you see about the propulsion systems, you just see this carefully, the rocket equations, because the first the figure shows that when there is an equilibrium, there is no moment, because all the forces are balanced. When there is an unbalanced force, according to Newton's third law of motion, when there is an unbalanced force, only the object will start moving. Okay, so exactly here in the rocket propulsion systems, the fuel and oxidizer or the propellants. So this is burned, and after that it is let go through a nozzles. So because of exhaust, so the thrust is created. So the thrust formula is given because of the thrust. So what is happening is because of exhaust velocity, so there is a change in the velocity. So when the rocket was having a mass of, so this, when let us say mass m plus delta m. Delta m may be this may be in the multi-stage rocket. It can be first stage, it can be second stage, or a single stage. It can be the mass of the propellant. So when the mass propellant is burned out, then this delta m is not there. So when it is not there, what happens is this has gained a delta b velocity. Okay. Then after that, we also can find out that how much efficiently the fuel is being burned or utilized. So that is given by the specific our ISP. Okay. So from, if you substitute here exhaust velocity, so all are related to the exhaust velocity, and we can finally arrive to what is the change in velocity in terms of G and ISP, and this is the change in mass. So this is called the famous Tsiolkovsky equations. Okay. So the propulsion systems, liquid propellant systems, solid propellant systems, because there are advantages and disadvantages in the solid propellants because the fuel and oxidizer. And you must know that in the propellant systems, oxidizer is always common because the combustion has to take place and the combustion needs oxygen. Only what is changed the fuel. Okay, the fuel can be either hydrogen, and the oxidizer will be always oxygen, and the fuel can be methane. What Dr. Ganesh also explained, that the methane was the fuel. So why the thing is, this methane, because if you see the other space programs, okay, not only for ISRO, other space agencies, if you see the famous SpaceX and NASA, they all are using the methane rocket. Okay, methane is a fuel, and this is the future fuel for everything, for exploring lunar, the Mars explorations, for other planetary exploration as well, because methane is a very availability wise is abundantly available, and it has a higher actually energy density, more than is almost 3.2 times of the liquid hydrogen in the volumetric energy density. So because of this one, in the actually the what happen is, in the same volume you can actually store more energy, and in less space you can have the more payload mass. Okay, so it has efficient combustions and cryogenic properties, because if we compare the liquid methane and liquid hydrogens, the temperature of this methane is more benign than the hydrogen. So it has certain benefits, and it is completely burned when it is burned, and it has a reusable, and in the Mars context it has a in-situ resource utilization aspects, as Dr. Ganesh the lectures you have seen. So another area where you can work, because I am not listing about all the things, because what happen is you have to think something new and try to develop, okay, in your either MTech program or your MTech project or BTech projects. Okay, so what is happening is in the electric propulsion, so what is happening is this is neither your liquid or nor gas. So here the propellant is being used is mostly commonly xenon and krypton and argon. Okay, so here what is happening is this the propellant is fed here, the gas, let us commonly use is it, let us say the xenon. Okay, xenon atoms are fed here using electron gun. Then after that, these electrons, these ionize these that the green atoms, that is actually neutral propane atoms. Then after that, ionization means it creates electrons and ions, okay, positive ions and the negative the species. So these ions using an ion optics, then these positive ions are actually coming out through an exhaust. Because of that only now the thrust is created. Okay, so in this electric propulsion, there are various variants are there, but here it has more actually the ISP than either solid or liquid versions. Okay, so this is an area where you can work and you can think about how to improve, because there are different variants are there. And why xenon is used and then either krypton or argon is because here you need energy to ionize it. Okay, to ionize the neutral atoms, okay, of the propellant. Here the ionization potential is less for the xenon, okay, then krypton and argon. Because of that only it has less power consumption. Because of that only xenon is being commonly being used. But in the SpaceX program, when there is a commercial, because krypton is more commonly used because of the commercial benefits. Another technology for propulsion, okay, is a solar cell for interplanetary exploration. In a solar cell, what is happening is this is called propellant-less propulsion, because here there is no propellant at all. In other things, at least there is a propellant. In a solar cell, there is no propellant at all. So these actually they have a very large area. Then when the solar radiation, okay, solar that is a pressure, when the sunlight falls on this, photons hit on that. Because of the particle nature of the photons on this large area, they create some pressure, because pressure is a force per unit area. So area is this one. So because of that, only certain thrust is generated. So because with that thrust, it is being sailed. Okay, so this is called a propellant-less propulsion. It is also very important area. And another very upcoming technology is called antimatter propulsions. When we talk about antimatter propulsion, so let us say this is the most commonly used and advanced technology, okay, in the propulsions. Antimatter, what do you mean by antimatter? Let us see. So I'll just little bit elaborate about this antimatter propulsion, because what happening, this is an area where you can actually work on further, okay? So antimatter means they'll exactly look like they are corresponding particles in this matter, except they have opposite charge. If you see here, what is happening is, this is our neutral hydrogen atom, okay? It has a proton positive charge, and it is electrons, one electrons revolving around a nucleus hydrogen. But in antimatter, what happens is, this antimatter of proton is antiproton. It will have a negative charge, okay? And mass is same, everything is same. Then in electron, it will have a positron, okay? So this will be actually moving around the nucleus, antiproton. So this is like the same for the matter helium, okay? So antimatter is made for antimatter propulsion. Antimatter is the propellant. So you have to make the propellant first. So for that, antimatter, how is it created? Antimatter is created in a very large, actually, the accelerators. Okay, so the particles of the atoms, they will be accelerated to very high speed. Because of the acceleration, what happens is they actually allowed to hit on a target. After hitting there, some light is emitted. Okay, so from that light, what happens is the emission of light itself, because there is a phenomena. Okay, so if you see the atomic theory, either there is a transition of in between the two levels, or otherwise there is a annihilation. Okay, so here the annihilation is the principle. So because of that, only some energy is generated. Okay, in terms of photons. So for every 100 photons that hit the target, there can be actually yield of 1 antiprotons. But we need more antiprotons for propulsions. Now, how it is stored? Because what is happening is antimatter cannot be simply stored like the matter, because antimatter, when it comes in contact with the matter, it will annihilate, and after that it will lose. Okay, so therefore they are actually stored in a very particular container called a penning trap. We will have special magnetic systems and electric fields. Then after that, they will be actually stored in a floating condition, because they cannot be in contact with any matter. Okay, so the storage certain capacities are today's technology. This is where you can work into to certain extents, because you can take up as a project, like how to make such kind of storage systems. How can you make like a generation systems, pair generation systems. So earlier, because of these limitations, there was a what is that the lag in the progress in the antimatter propulsion systems. But see, recently there is a breakthrough that also I will come in the coming slides. So I told you that antimatter power is created due to one process called annihilations. Okay, when you can see here positron and electron. Positron is the antimatter of electron. When they come in contact, two pairs of photons are generated. The mass, the energy of the photon is 0.5. Okay, 0.5 million electron volts. Total energy, if you multiply here, this will be like 1.02 kind of million electron volts. If you see, this will be the gamma ray. Okay, so the energy content, if you see the energy content of this process is 90 to 10 to the power 16 joules per kg, which is the highest energy density of all the non-propellants. Okay, so because of this only, is almost billion times more than hydrogens and oxygen systems. Because of this only, it has a huge potentials to use as a propellant system for our planetary exploration as well as the interstellar travels. I told you that there was actually a bottleneck in the generation systems like pair and anti-pair productions and as also these storage systems. But recently there is a breakthrough in 2018 and 2025. There were two scientists called Hui Shen and another is called Stenson. Okay, these two actually came up with breakthrough experiments. Then they are able to create a reasonably good amount of matter, antimatter, as well as the storage systems. After this one, what is happening is, after this one, they propose, okay, the present configurations of the antimatter and matter propulsion system is we should have these components. One is I should have the power systems, because the power system, I told you that everything needs power. Okay, so and because this then this power source will be the fission-based nuclear reactors kind of things is what is proposed, and a pair and the particle generator. Here, whatever that Hui Shen's discovery, high energy laser, they actually let it hit to a goal kind of target substrate. Here, this is a power source, and this is a production systems. Then there is a substrate, this is the laser source. Then after that, laser source will bombard this substrate. Then actually pair and pair of particle and antiparticle will be created. Let us say electron will be created and let us segregated to this collected through this part, and another is positron is collected through this part. Okay, so these storage systems, these are called the tokamaks. Okay, tokamaks is here. This is the typical. This one is a magnetic systems with a donut shape. Then after that, they will be injected here. Then annihilation will take place here. This particle and antiparticle. Then huge amount of energy will be created. That exhaust energy is created to propel these systems. So this is the idea. So here, what is happening? See, in this Tsiolkovsky equation, so the change in the speed is directly proportional to the exhaust velocity as well as a logarithmic of this change in the mass. When such kind of matter and antimatter, because it's electrons and protons, positron, you know, electron mass is how much? It will order of 10 to the minus 31 kg. It is negligible. So here, what is happening is when annihilation takes place, there is a negligible change of this mass and the initial mass and the final mass. So keeping this constant, what is happening is change in velocity is directly proportional to the exhaust velocity. Since it is a like mass, the light, so exhaust velocity will be in what order? In the speed of light. So let us say the 3 into 10 to the power 8 meter per second. The change in velocity with time, with that accelerations, it can have the very good speed as compared with other systems. So a matter and antimatter spacecraft, this is one typical calculations. So around 10 ton spacecraft with electron and positron annihilations, with this their discovery, SUI as well as the Stensons, with a 6 into 10 to the power 17 pair particles per second, they can have an acceleration of 2 meter per second square. With this, the spacecraft can reach eventually around 40% of the speed of light. So if the spacecraft is having a 40% of the speed of light, then what is happening is with 10 grams of antiprotons, the Mars missions, we can go in 1 month. Otherwise, conventional actually rockets can take will take around 11 months with the present propulsion systems. So the 11 months can be reduced to 1 month. And moreover, our nearest this Alpha Centauri, I told you in the, that beyond our solar systems. So that will be in the, we can go in 40 years. That means within our human lifetime. Or otherwise, actually, it will have taken around 1,54,000 years, which is not possible for us to travel. So there is a kind of rocket, there is a kind of technology which will stimulate you to think. Okay, so because there is a lot of emerging researches going on in this area. Another part is robotics. As I told you, the robotics is required for accessibility to the harsh environment, then long distance explorations, and we can teleoperations. These robotics can be controlled from here, though the rover and the lander are there on the surface of the planets. We can control from here, that is teleoperations. And they can also do a lot of in-situ analysis and they are precursors, because actually they are precursors to human missions. Okay, so when you come to the robotics, there are two kinds of robotics. Okay, one is robots, wheel rover, and another is leg rover. So they have a different actually pros and cons. So, but what is happening is, see, the leg rover, like human beings or like this quadruped. Okay, so they can negotiate these different terrains very easily. But however, wheel rovers cannot do. these steep kind of things, like you see, Dr. Das also might have told you that, because you see, whatever the missions so far we have done is nobody has explored the craters, because the crater walls are very steep. Okay, so since the crater walls are very steep, the rover cannot go down and actually climb up. Okay, so because of that only, what happens is crater walls are remain unexplored till now. So how if we have such kind of black rover, means they can climb it. So this is one area where you can think, because this is a new emerging area. So and another area is where if you combine these two, what will happen? The features of this wheel rover and leg rover, if we combine, then both actually the features we can get it. So and let us see, that will come realized to a reconfigurable rover. When we say the reconfigurable rover, what do we mean by reconfigurable rover? Because the mode can change. It can change to the rolling, to the crawling motion. So it's now we'll see here. So this is one kind of spider, because these are actually such kind of designs are derived from the nature. Okay, so this is one kind of spider in Morocco. So this spider, otherwise it will normally work, but when it is actually threatened, it can do such kind of cartwheel motion. You see, you can see here. So they will actually escape from the danger very quickly. Okay, so this let us see. This is one rover. Then after that, it will change its gate configurations. Okay, so how does it change? You can see this simulation. Now it will roll now. So it can roll now, it is safe also. So this is how it changed. Now, let us see here how it is rolling. The rover will roll now. Earlier it was actually it can crawl also, it can roll also. So this is how actually the things. So this is one area nobody has realized such kind of a rover. So these students can take up as a project and then actually try to conceive such ideas for future explorations. Then I told you that most of these base designs on this technology are derived from the nature. This is called the biomimicry. Like you can see in the picture that how we have derived this rolling and crawling, then the design of this train and an aeroplane, so many things. Okay, so this has to be, we have to adapt. I told you that this already I covered. Okay, the crater challenges, which is unexplored area. And so now we have to think something about, again, crater wall climbers as a solution, as a biomimicry. So biomimicry, if we do it, so now let us see here. So these are the crater wall climbers which are under development across the globe. The NASA is developing a Scorpion with a leg rover, if you see here. So how many legs are there? Like a Scorpion, it has many legs, multi-legs. This is the NASA. ESA is developing another space wall climber. So it is also another leg rover. Then Aramis ISA is again developing another such kind of reconfigurable rover kind of things. Then ISA is another developing, this is a different type of wheels. You can see how in the different terrains, how can negotiate. Okay, otherwise it will be actually stuck there. Then another is, you see, lava tips you may be knowing in different planets. So like snake rover, it's called snake boats. So there will be a teeter with the primary and this one mother rover, and this will be like a daughter or what kind of things. They will go and a camera will be fit here. Then after that, they can do the in-situ analysis and come back again. This is one area where inaccessible areas can be explored. Okay, this is called a nanocode. This is derived from our this is kind of you know that our tank, war tank kind of thing. So different these shapes, then designs you can actually think over, so that this new revolutionary technology, enabling technologies actually come up. Okay, so here what I want to tell you is, in here what happens is, in multi-leg rover, no, this will not be like a centralized. The challenge is this will not be like a centralized control systems. Each leg can independently control. Okay, can move independently control, because whenever one leg is suppose stuck, then this leg itself can be controlled. Okay, independently. Such things are very important. Now you see the having, you know, Chandrayaan 3. There was two instruments which measured this about a moonquake, okay, the vibrations, and another is the surface temperature up to 10 centimeter. There are 10 sensors, they are called the SASTE, surface temperature measurement. So we have this temperature profile for on the surface temperature. So what it shows was around 10 actually kind of things from here. If you see here, from 1060, then over, you see here, from 0 to 80, okay, 8 centimeter distance, there is a temperature difference of 10 to, that means minus 50 kind of things, okay. So here what is happening is 70. So temperature difference of around 70 was there, okay, 70 degree. So what is happening is, in the 8 centimeter, 6 degree, around 10 centimeter, it will be around that 70 degree. So it says that there is a temperature variation. So from this, what you can extract the idea is, maybe knowing about the thermoelectric effect. So when there is a surface, there is a difference in the temperature, you can actually create about thermoelectric and a Seebeck effect and try to generate such kind of sources, power sources. This is one area where you can think. And another area is, now having done up to surface 10 centimeter, we actually should drill it further and then try to understand what is below. Okay, so what is the composition, what is the temperature difference? That is the area for the another for core drilling systems, because the deferred samples should be studied. Okay, another is in situ resource utilization, what Dr. Ganesh has already covered, that we have now understood from our mission that what are the actually available resources. We have detected different elements there. So from these elements, whether we can extract something, okay? So I think this already covered. We have a solar simulant, okay? We have a simulant which was tested for Chandrayaan missions. So this simulant is very exactly equal to the Apollo 16 simulant, and this is available in the Tamil Nadu one area, okay, in the Salem. So this is very similar to our this is a patented actually item by ISRO. So it is very similar. From that you can do the in-situ resource utilizations. So Dr. Ganesh already covered that how to use using the simulant, whether how can we extract the oxygen from there, and we can make the space bricks, okay, because if we want to make something, some structure there, we have to make bricks. From that we can, these are already demonstrated by ISRO and IAC together, okay. So another is Mars approach is already covered, that there is only one oxygen extraction strategy, or electrolysis of the carbon dioxide. And this was the question came, that instead of the carbon monoxide and oxygen, whether we can do the carbon and oxygen. That was being discussed in the discussions. I have seen that one. Another is only hydrogen strategy. Okay, this is oxygen only extraction. This is hydrogen strategy. From that oxygen, carbon dioxides, and with the reductions of the hydrogen, we can actually produce this kind of methane and water. Then complete strategy is, then what is happening? It is water electrolysis. Okay, so water electrolysis will give again oxygens. Just now in the discussion I heard about this. These life support systems need oxygen. That is what Dr. Ganesh answered, that we need the ECLS system, that is our environmental control life support systems. We need oxygen generations through subarterial reactions. That is a part of the in-situ resource utilization. Another area is where you can think and is like biomimetics, that is called the self-healing materials, because in the space environment planetary systems, because we cannot, if something happens, then we cannot go and repair there, because it should have a certain property that it heals by itself. Okay, so that is a motivation, that there is a since there is a lack of the atmosphere, like a moon, the radiation is very harsh, and then there is no magnetic field. Okay, because of no magnetic field, radiations are directly actually coming and hitting on the bombarding on the surface, so sputtering is taking place. So in such situations, what happens is, these materials can get actually the cracks, and it can have issues. Okay, so life support systems there, let us say the inflatable habitats. So now this also biomimetics. We know the biology of healing when actually our skin is cut, because there is a process inside, then it will heal actually with the flow of the blood. Okay, from this. The same thing is applied here in the healing. So what is happening is, the concept is, the material, that means which is actually flown, taken, or there, shall have the fiber or microcapsules already pre-filled with resins and catalysts. Once a crack is developed, the fibers and the microcapsules will break and release the resins, and a polymerization will take place, and healing is achieved. Okay, here what happens is, this is a microcapsule based approach. You can see here the materials, inside the materials you are already filled with the microcapsules, which are having pre-filled with the healing agents. So when the crack happens, when such this is broken, so the material inside will come out and in contact with this catalyst. Then after that, the polymerization will take place, and this crack will be healed. Okay, this is how that should be done. Another is a fiber-based approach. Like here, that is the micro capsule, means suppose spherical in shape. Here it will be like a tubular kind of things. Inside its tube, there will be two different sets of tubes. In one tube, resin will be filled. In another, hardener will be filled. When the crack happens, the resin will flow to the crack. Then polymerization will take place and a crack will be closed. Okay, this is one area where you can think, because not many such materials are available in the market. You actually, the chemical engineers, you can think about how to develop such kind of systems. Okay. See, these have a lot of application in space: composite structure, electrical wires, your PCBs, then propellant tanks, re-entry thermal resistant materials, human space suits. You know, maybe knowing that our astronaut suits, inflatable structure, habitable housing structure, they can be actually crack can be developed. But if they have the self-healing properties, you no need to intervene, that they will heal by themselves. So I told you that in the market, not many are available, but in the these are some actually 1-2 materials which are available in the market. That is called a photo cell graded layer. Okay. So Dr. Praveen, this my voice is audible, no?
Yeah, you are very much audible.
Okay. Because actually, because I am not sure. Yeah, fine. So this one photo cell graded layer, which actually what happens is when it comes into light, then after that its surface will be modified and it can have the self-healing properties. So, and another is self-healing using such kind of Nucrel. This is called a brand name called Nucrel. This is another materials. It has a self-healing properties. Okay, so this was already been in the International Space Station kind of things. Okay, so it has been used in the MLI, that the multilayer insulations caused by the small debris and meteorites. So there is an area where you can think about, and having discussed about these certain materials and robotics and propellant systems, let us quickly see about the communication. Because I told you that communication is not easy. Long distance communication is very difficult, because in long distance communications, there are actually many challenges. Okay. Because you should have a high data rate, and moreover, whenever during your visibility time, you should download the data, and the data rate should be very high, and a large volume you should download in a very short time, and you should have as real time communications. So such things what happen is, and moreover, you should have entire networks. In this develop where you can think about is optical communication and quantum communication, because RF communication almost there is a measure enough technology is there. These are optical communication, and quantum communication is something which is booming. Okay, so what is happening is, I told you that in a long distance communication, Mars and let us say Mars to Earth communication, approximately 1.6 astronomical unit. So here, when that is RF, okay, when RF reaches here on Earth, this beam divergence is too wide that it's almost cover 100 Earth diameter. Okay, so the spread is too much. Because here what is happening is beam divergence is generally calculated lambda by delta. When the wavelength, when you say the optical communication radio frequency, you can see here, radio spectrum will have the longer wavelength as compared to the optical wavelengths. Okay, so longer wavelengths will have the larger beam divergence. When it travels here, then after this, what happens is, once you know theta, then you can calculate what is the r theta. Okay, from the that you know no, that how to calculate the arc. Once you know the theta, then you can calculate, you know the distance between Mars and the Earth, then you can calculate the r theta. Then you have the divergence, how much actually footprint is there. That footprint is so large. So lot of actually useful information is lost, because we cannot have such kind of antenna, big diameter antenna. Okay, so what is happening is in the optical communication, this beam divergence is very narrow. It is actually your the footprint is very narrow. So therefore we can get in a smaller antenna, you can collect all the informations. Okay, so and moreover, in the optical communication, high data rate is there, and generally this is a one term used in the optical communication that is called a swap. That is size, weight, and power. So these are all less. Size almost 50% less in the mass, 25% less in the power. Okay, so this is, and moreover, one very good area is in the license and coordinations in terms of this international policy. In RF, it is actually well controlled by ITU, International Telecommunication Unit. But optical communication, as on today, the frequencies is free. The license has not come yet, so anybody can use it. Okay. Now, coming to quantum technologies, this is one area you know that because this is of national importance, in the sense that our Prime Minister, Honorable Prime Minister of the country, has announced national quantum mission is already approved in April 19 of 6,000 crore. Okay, so therefore the whole country is working, and you are also actually one stakeholder. Students should work and think on this booming area, and all the quantum technologies can be classified into 4 verticals. One is quantum communications. That is quantum communication means here what we are looking is a security. Okay, so it can be done is a secure communication. Whatever I communicate to you, nobody can listen. Okay, nobody can tap it inherently. Now fiber and a free space communication can happen here. Another is quantum sensing area. You know, several sensors, you can do the remote sensing, you can do actually call atom interferometry, and with enhanced sensitivity. Suppose if you want to see the, let's say, if you want to see whether our art is having whether water resources inside or how much water resources being depleted, all these things can be done with your gravimeters, gravity mapping. Okay, so that gravity mapping in the quantum sensor, you can have 10 to the power -10 the G kind of things. It's very enhanced sensitivity. Okay, so with that we can find out. Another is like quantum computations. Okay, so that is for enhanced speed, and you can do the simulations and this one. Another is like you can do different computation simulations. Another is quantum materials. So what is happening is quantum communication, why it is required? Secure communication. Quantum sensing, why it is required? Enhanced sensitivity. Quantum computation, why is required? Because enhanced speed, because it can do faster communication than our actually these conventional computers. Okay, and quantum materials, you can do a lot of revolutionary materials, including nanomaterials. So this is the quantum communication, because in the planetary explorations, whenever you and when you explore it, you should have secure communications within your actually domain, or so that no other actually the party can hack that important information. Okay, so here it will have, this is transmitter and this is the receiver. These two parties want to communicate. These actually want to communicate to this person. So in the quantum communication and RF communication will have only one channel where the RF is being transferred. Okay, and this being modulated. But in quantum communication, there are two channels are there. One is the natural RF, the channel also will be there. That is called the classical. And another part is it could be RF also. It couldn't be actually anything. Okay, so another unique channel called the quantum channel. This is the unique feature of the quantum communication. So in quantum communication, you need two channels. In RF communication, you need one channel. In the quantum communication, you need to transfer the key, because when you communicate, if you don't want to reveal, because the message should be encrypted. Okay, so this encryption was there during the king's time, because when one king wants to send a message to another king, they will actually do such kind of this one hide technology. They will hide a message. Then after that, once the message reaches to another king will do such kind of decryption technology and try to read it. So the key will be communicated through this quantum channel, and a message will be communicated through this classical channel. And a classical channel is also required to create the quantum key. Okay, so how it is secure? It is secure because of the quantum principles. So Heisenberg's uncertainty principle, you may be knowing. Okay, Heisenberg's uncertainty principle, inherently it tells that the measurement disrupts the systems. Okay, whenever any party wants to eavesdrop or tries to actually let us say steal some information, then after that what happens is it will go unnoticed, because the Heisenberg's uncertainty principle says that trying to know something itself is a measurement. Okay, so measurement will disturb the systems and it will reflect it in terms of error. Okay, in the communication, because they measured error continuously between these two parties, whether somebody has come in between them. And another is a quantum entanglement, you may be knowing, and another is no cloning theorem. These are actually, I'm not going to elaborate, but quantum entanglement is a very, very booming technology. I'll be briefly touching upon no cloning theorems. That theory says that quantum systems cannot be copied. Okay, cannot be cloned. You may be knowing about these biological copies, cloning, and all those things, but in quantum, the cloning is not possible. Okay. So different applications are there in the banking sector, in the navigation sector. If you want to distribute a key, if you want to secure your actually the assets in the ground assets, space assets, and the government assets, defense assets, personal assets. Okay, and all those things actually should be encrypted with quantum communications. And different protocols are there depending upon the types of this one. One is a prepare and a measure. There is a BBAT protocol, Bennett and Bressart in 1984. Another is a decoy state, BB84, and that is a B92, Bennett 1992, it was introduced. The entanglement-based protocol, BBM92, Bennett, Bressard, and Mermin, okay, in 1992 it was introduced. Then E91 is ICARD in 1991 is introduced. Then another, these actually class of these two are called discrete variables, okay, QKD. Then this is called continuous variable. There is another set of protocols. In a discrete variable, it says that the polarization state is used to actually encode your information. In the continuous variable, phase is used, okay, and here a single photon is used, and here actually a single photon is detected. Here in the continuous variable, your phase is used, and instead of the single photon detections, it will do the field measurement in terms of homodyne detections and heterodyne detections. Okay. So just because I want to actually stimulate your mind, because this is a very important area in quantum communication. It can be done. I told you that from satellite, one satellite will actually transmit the key to one ground stations, and it will go to another station, transmit the key, because both the satellites now will have this what he has transmitted here and what he has transmitted here. Then later on, he will combine these both the keys and transmit to another ground station. Okay, this ground station. And that ground station will do certain operations called XOR operation. Then after that, he can retrieve key. So then both the ground station will have the same key. So then same key means it is called symmetric key distributions. So in a quantum communication, symmetric key distribution is performed using some mathematical operations. Then after that, the same key is being used by this station to encrypt a message and send to this station. Then since this person is having the same key, he no need to ask to this person, and he can decrypt the message. Okay, so this is how the secure communication is done. And this key, there is no way for any other party to steal or to know the information, because this quantum mechanically is generated. And another way is actually here entanglement-based photon communication. Here, instead from entanglement means two pair of photons will be generated and distributed from the satellite to one ground station, another two ground stations. And after that, what happens is independently they will do the processing and will have the same key. Okay, because these will be identical photons. So if you see here, so far in the world, only right now there is only one quantum technology demonstration in orbit, which is done by another country than China. Okay, other countries also trying to do it, but this was demonstrated in 2018 timeline, and they have demonstrated everything. Okay, and they are having very advanced in the quantum technology, so we are also have to do it. They have demonstrated from satellite to ground different communication schemes. Okay, and they also have done from one continent to another continent, and they also have done the entanglement communication from the satellite to ground. And another is they also have done the teleportation. That means actually these are transportations of the quantum state from one state to another place. Okay, so that from ground to satellite they have done it. So this is how they have done it, from actually one station to another stations. And this is how I told you that satellite, the Messier satellite, will transfer the key to one station called Graz and Qinglong. And after that, this operation was done, and they have done the such kind of communications with this area. Okay. Another area is quantum entanglement. Okay. Quantum entanglement, you know, entanglement. When we say the entanglement, there is no such kind of individuality. Okay. All we have to talk in terms of togetherness, like a teamwork kind of things. So when two photons or two objects are entangled, means that they cannot be dealt separately. They have to be dealt together. Okay. So if I know the state of the one, I automatically the other state is known. So therefore, Einstein told that this is called spooky action at a distance, because irrespective of their distance, the measurement on one actually that object or a particle will reveal the parameters or other this one counterpart automatically. Okay, and this is different from the superposition state. You must know that. I will not explain here. Then this is what a mathematics. So I will not go here. Now from here, what is happening is yeah. So if you see two photons, okay, two photons. One is it will have the polarization state, horizontal polarization. Another is a vertical polarization. In terms of bit coding, if you this one 0 and 1, you can do actually this kind of computing. That is how it is done. Okay, so when you say a qubit is basically superposition state of the two states. It could be your horizontal, vertical, or 1 or 0. So that means when we say the bit, it could be either 1 or 0. But when we say the qubit, it will have a superposition state of 2. But the measurement, when you measure it, you will get only one state. Okay, that is called wave function collapse. So Bell state means maximally entangled states. So in a Bell state, when you have such two states, you can have you can create 4 states which are entangled with each other, and they are called maximally entangled, means Bell states. Okay, and this is in the name of one scientist called John Bell. What do you mean by maximally entangled? Because this is area I will not explain. Okay, there is called entropy. Entropy in quantum mechanics, though you just read, when we calculate the entropy of this Bell state, that entropy will be maximum. Okay, that is called the von Neumann entropy. So there is a certain actually process to calculate it. So what you have to remember is ice BB HB BH. So 1 and 2 subscripts you can add later on. Okay, these are called Bell state. So when you do know, when 2 photons are entangled, what you have to remember is there are 4 Bell states which are maximally entangled. Okay. So how to create this entanglement? This is called process called spontaneous parametric down conversions. Okay, and another process is there called 4-wave mixing. Okay, so from the takeaway, what is the takeaway from this? How to create the entanglement photons? One process called is spontaneous parametric down conversion. Another is process is called the 4-wave mixing. Okay, so here is spontaneous parametric down conversion. What is that? So when you have a nonlinear crystal, certain type of BBO kind of things, the beta borium oxide. So when one photon called a pump photon of higher energy is incident on this crystal, some actually such kind of nonlinear process takes place. That is called spontaneous parametric down conversion process. And at the end, it generates 2 photons which are entangled. And one is called a signal, another is called idler. In this process, both energy and momentum are conserved. Okay, so therefore, whatever photon energy was there, it will be sum of these 2 energy. Therefore, what happens is the wavelength here, let us say here, the wavelength, it will be the here double of this wavelength. And in terms of frequency, it will be the half. So if you have here 405 nanometer, it will have 810 nanometer on each photon. So there are 2 types are there. One is type 1, type 2. I am not actually dwell on this much on this. And here, let us see it here. This is where actually. So it has a one horizontally polarized one actually cone, and it has a particularly polarized. When these 2 cones intersect at this point, diagonal points, you can hear here. This is called entangled photons, because at this point, this is superposition of both horizontal and vertical polarization. At this point as well is a superposition on the both horizontal and vertical polarization of equal probability. Okay, this is like a Bell state. So at this point, so it has a actually what happens is it is a superposition state as well as a correlated. So, but when you measure, it will be either horizontal polarized or vertical polarized. So these are called entangled photons. Okay, this is how it is generated. And it is type 1 also is different. And how do you know that these photons are entangled? What is the way to measure? Okay, so that is called, I told you that like a Bell state, John Bell has made a certain calculation, is very complex calculation, but at the end, he derived a limit called the Bell's inequality. He says that there is a certain parameter called S, okay, that is called the Bell's parameter. So basically, this Bell's parameter, if it is entangled, then that Bell's parameter should be between 2 and 2 root 2. Okay, so what is happening is, so maximum value is 2 root 2 and minimum value is 2. So it should be more than 2, but less than, it will be 2 root 2. So then when you measure this kind of correlation, I told you that entanglement is nothing but a superposition as well as a correlation. So when you measure the correlations, then this correlation parameter, if it is more than 2 and less than 2 root 2, then the photons are entangled. Okay. Another area is of this entanglement is entanglement swapping. Why entanglement swapping is important? Because when we do the communication, so how the internet is actually arrived, because internet we can do is all multi-node communications that are like constellations. Okay, so you may be knowing about these Starlinks, the like constellations and all those things. So the same thing for quantum internet. If you want, we need instead of node-to-node communication, you need actually multi-node communication. For that, entanglement swapping is the solution. So what entanglement swapping says that These Elias and Bob, okay? These Elias and Bob are entangled. Kati and David, these two parties are entangled. What happens is, when you measure, these perform some measurement called a Bell-step measurement. After that, what is happening is, these Kati and Bob, they never met each other. They are not entangled. But what happens is, after the measurement, they become entangled, and these Elias and David also will become entangled. So whatever entanglement pair are there, it actually is no longer entangled, and it creates another new pair of entanglement, which was never entangled earlier. So this is called entanglement swapping. Okay, this is one area where you can think. And another area is quantum.
Yeah. Please speed up. We have to finish.
How much time, Dr. Praveen?
Only 2 minutes.
Okay. Yeah, done. Yeah, I will just wind up. Okay. So this quantum teleportation is something where you can actually transmit one photon, one quantum state to another without physically actually transfer. Okay. So and now this low temperature lithium-ion battery is something I told you that this actually power is required, but normal battery cannot work below 0 degree. But this is something because Dr. Ganesh also mentioned that lunar environment itself is minus 180 degrees centigrade is there in the night. So how the battery will work there. So there is certain types of batteries which will work below negative temperature. So these instead of going here, the lithium ion, because these are certain technologies, you have to work on 0 volt technology, novel electrolytes. And here I can show you, these are low temperature lithium ion battery. And another is the normal battery. When you walk up to minus, when you pull down of the minus 40, then it can retain up to 90% of the charge. Okay, but all the conventional batteries will have 0 charge. This is kind of batteries you have to nibble. And another is a rollout solar array, because everything needs the solar power generations. So the solar array, this is something which is you can roll out when you want, and when you don't want, you can roll it back. This is more suitable for planetary exploration. When you are having the maximum radiation exposure, you can roll it back, and then when you want, you can again roll it out. And this has been implemented in the International Space Station as well as the DART stations. DART missions, you may be knowing about the double asteroid collision. Okay, so yeah, this is the last slide, Dr. Praveen. Yeah. So we have a lot of opportunities. Antimatter propulsions, you can think about electric propulsions, better one, reconfigurable rover, swarm rover, means all the actually small rovers can work together. You can define a control together and do exploration. Snack boards, optical communication for faster speed, cell helium materials for cell low temperature battery, quantum technologies, quantum teleportation, entanglement swapping. I have not covered about the radioactive heating unit, thermoelectric generator. Stirling engine is where you can think about, okay, because this has been demonstrated by China in the Chinese space station recently, and no one has done that. And rollout solar array. So we have many more exciting areas for you. Yeah, thank you. Thank you, Dr.